All right, so basically we just proved that postulate SSS works. So if you know that three sides in two triangles are congruent, then you know for certain that the two triangles are also congruent. All right, so what we're going to do now is look at some proofs. So there's a couple different ways we can write a proof. We can write a two-column proof or what we call a flow proof. And basically what you're doing is you're listing out a series of steps that you took to ensure that you can say for certain that the two things are congruent. So you're basically working kind of like backwards. So you're saying these two things are true, and you're going to work backwards to prove that those two things are true. So let me show you how it's done. These are some tips. So first you want to read over your given and your proof statement. So what you'll see is anytime you have a proof, you'll be given some information. So that's here. And then this is what you're trying to prove. So we're trying to prove that these two triangles are congruent. Remember this symbol right here means congruent. With an equal sign, with a little squiggly line like that. Okay, so that's step one. Step two, we want to mark up the diagram with the given information. And so what we're going to do here is we're going to use tick marks because these are side lengths. So AB is congruent to RS, AC is congruent to RT, and BC is congruent to ST. So that's step two. Step three, you want to match up corresponding angles and sides in your head. So we did that. And then you want to set up your proof and use all of the given statements. So what do they mean by use all of the given statements? Basically what it says. So if my first statement here is that AB is equal to RS, and that was given. The second statement is AC is equal to RT. That's another given statement. And then we were also given that BC is equal to ST. That was given. And since we know all three sides are congruent, we can say that these two triangles are congruent because of the side-side postulate. If you know all three sides of a triangle are congruent, then you can also conclude that their angles are congruent. All right, so this is what a flow proof looks like. If we were given a two-column proof, you'd have your statements on the left and your reasons on the right. And then again, we would fill this in with given and fill this in with given. Okay. When we start out in this process, I'm going to pretty much give you a bank of reason statements, but and as we get better at it, you'll be able to do these on your own without having any kind of help. Okay. So let's look at another example, and we're going to do a flow proof for this one. So we're given these two triangles, and you'll notice they kind of overlap. Okay, so sometimes you have to look at a picture and kind of go beyond given information and kind of make some conclusions on your own. So for example, this picture has already been marked up for us. However, there's one piece of information that hasn't been marked, and that is that this leg on both triangles is also congruent. It overlaps. So both triangles contain that leg, and so that's some information that you're going to have to notice and mark on your own. But if I look, I'm given this information, and I'm trying to prove that these two triangles are congruent. And so the first thing I'm going to say is that LM is congruent to LP. That's given. Here's my reasons bank. This is my second given. Okay. This property right here, when the line or the angle overlaps itself, we call that the reflexive property. You'll also see it if you have a triangle and then you have a second triangle within that triangle, like that. This right here, this angle, because they overlap, you know that they're congruent to each other. And that would be another situation where you use the reflexive property. Okay, and then the last statement, we used given twice. The last statement, because we know that all three sides are congruent, you can say for certain that these triangles are congruent using the side theorem. Okay, and again, this is a flow proof because one flows to the next, and you'll see it written a couple different ways. All right, and once again, we're given another flow proof. This is our information that's given. You'll notice I don't have the word bank here, but it's probably going to be about the same. One thing you can mark up that hasn't been marked up is this side right here. You see that it overlaps on both triangles, so it's going to be congruent. So let's look at our given statements are here and here. So I can just go ahead and write given. And then if you remember, AC is equal to AC, we call that the reflexive property. That's just something you got to memorize. And then to prove that those two triangles are congruent, well, we can see we marked up all sides. So it's the side, side, side postulate. Okay, let's look at another situation here. This one we're going to do a two-column proof. And again, it's your choice. On a test, you'll be forced to do one or the other, so that's why I've chosen to show you both. Now this has some interesting information. First of all, we're going to mark up that DC is congruent to AC. Okay. Now the second piece of information they're giving us is that B is the midpoint of AD. So when you think midpoint, you should be thinking middle. And so if it's in the middle, you can now mark up that this side is going to be congruent to this side. And that's just the definition of midpoint. And then lastly, you should notice that this line right here is overlapping on both of our triangles. So we know that's going to also be congruent in both triangles. So let's look at what we have. B is the midpoint of AD. Well, first, DC equals AC. That was given information. And then we've got B equals the midpoint. So you always want to get your givens out first. That was given. And now it says that DB is congruent to BA. Well, we know this because B was a midpoint. So if we're here, we're going to say definition of midpoint. Okay. And now we've got, so these are kind of like a mystery. I think they're kind of fun. We've got that CB is equal to CB. Well, that we can use the reflexive property. And then lastly, we can see that we marked up all three sides. We didn't mark up any angles. So we can say that this is congruent by side, side, side. So this is kind of fun. It's a little mystery of how to put things in order. Okay, so make sure you're marking up your picture first. And make sure you get rid of your givens. And then your last thing will be your proof statement, whatever you're trying to prove. So you need to finish your packet for homework, and then you have these IXLs due as well. Today is Friday, so they'll be due next week. Let's say next week, Wednesday. Okay? I think that'll already be close to March. So go ahead and get started. If you have any questions, let me know. If you need to get up and stretch a little bit, go ahead, but it's time for you to practice this stuff.